Do the following two regions have the same area? Now, the way that most students go about solving this problem is they compute the integral for the top area, and they compute the integral for the bottom area, and they say, hey, look, they're equal. And there's nothing particularly wrong with doing that, but I don't think it gets at the really what's going on with substitution. And that is that substitution transforms a difficult to find integral into an easier to find integral. All right, so let's start with this top one here, this top one. And we'll say the integral from 0 to 1 Okay, all right, so as you see, probably, let's see, we'll make a u substitution. We'll say u is x cubed minus 1, du is 3x squared dx. Okay, so let's see, this one, let's see, u of 0 is -1, and u of 1 is 0. So we get that. We have u cubed notice this is du. All right, now this variable u here, that's really just a dummy variable. This is the same integral as if you made that into an x. So you don't have to actually compute anything. You don't have to actually find the answer. You can just use substitution and say, okay, this is the integral from -1 to 0 x cubed dx. Okay, so they have the same integral, right? So we see that they have exactly the same integral. But let's see, what does it say? It says, do the following two regions have the same area? So their area isn't actually whatever the answer to this is, because this will give you a negative number, right? Let's see, that's x to the 4th over 4 evaluated from -1 to 0. So you put in a 0 in there. Right, so it's -1/4. Right, so the area isn't actually -1/4, right? That's just because the integral puts because the area is below the x-axis, it assigns a negative to it. Right, so if we assign, say, a1 to this region and a2 to this region, we don't really even need the fact that the integral is -1/4. Right, so it's not really correct to say, well, they're both -1/4, so that's why. Because the area isn't negative. The real reason is because this integral, as we see here, can be, or this top integral right here, this one, can be transformed through substitution into that one. And so what this says is that area 1 is the negative and that's why they're equal.